In the previous video, we generated this data that lied perfectly on a line. Here, let's see how to generate same sort of data, but where there's some randomness to it. And because it was a little cumbersome to go from X and Y to the Altair chart, let me write some code that outputs this chart for us. Let me define a function that outputs such a chart for us. So let's call it make chart. It'll take two inputs, X and Y, like the two outputs to make regression that we were using above. And then first I'm going to define this data frame inside, and then I'm going to define this Altair chart inside. And let me fix the indentation here by hitting tab. And I could write return here, but I think it's probably a little more readable if I call this, for example, chart, and then I say return chart. Okay, so now we can make this chart more quickly using this make chart function that I just defined. And this is an example where it would not make sense to use a lambda function because there are a few different steps that I was just doing here. Okay, so let's go ahead and copy our make regression code. And I'm going to use 50 points and one input dimension. Okay, that's like saying this is the input. There's just one input value. Or just one input dimension is a better way to say it. And then I'm going to say, how about noise equals 10? And let's say bias equals negative 14.5. So the noise, this represents the standard deviation of the Gaussian or the normal random variable that we add to each of the 50 points. The negative 14.5. So notice how this line goes perfectly through the origin. The true line goes perfectly through the origin. Now the true line is going to go exactly through 0, comma, negative 14.5. So the true y-intercept is negative 14.5. Okay, and then let's go ahead and display the chart. And so here you can see it has a little more randomness to it. And if I run it again, okay, I just ran this code about 20 times trying to find an example where it was, even though we used the same input values, where it looked totally different. So here's one where you can't even tell that it lies on a line. And so if we want to know what is the true coefficient in this case, there's no way to recover that, as far as I know. And so there are a couple ways we can fix that. So let me show you some of these ways. So for example, I could say random state equals, and I'm in the habit of always using an integer here. I'm not sure if you can use a float or not. But now if I run this a second time or a third time, always looks exactly the same. And that's because this random state is saying the randomness is somehow originates from this value here. And so every time we run this code, we're going to get the same output. Okay, if I changed noise to 9, it looks a little different, but actually more similar than I expected. Let's try like noise equals 0. Okay, there it definitely looks different. But as long as the other inputs are the same, then it's going to look exactly the same here. So that is one way that we can have some consistency, but still doesn't tell me what the value of the coefficient is. So if we want to know what's the coefficient, I can say coef equals true. And I get this error here, and it says too many values to unpack, expected 2. And so the expected 2 is because I gave it 2 variable names here, and so it's expecting whatever is on the right-hand side to produce 2 values. But because I changed coef to true, it's also returning the coefficient, so it's actually producing a third value, and so it gives it too many values for these 2 that I expected. So let's put an m here. And let's just guess what we expect this to be. So as we go from the x value to the y, x value of 0 to x value of 1, looks like the y value goes from, okay, I guess I need to go down here. Looks like the y value goes from about negative 20 up to about 70 or so. So I'm expecting the slope to be about 90 in this case. And so this m should hold the true slope. So let's see what m is. And I'm expecting it to be about 90. Okay, so I was off by about 10, but I was on the right order anyway. So m was about 80. And so this is some way where we can add randomness to our data. And now we can use x and y with scikit-learn's linear regression to try to find this bias of negative 14.5, which is like the y-intercept, along with this slope m, okay, this slope of 79. Okay, we'll see how to do that in the next video.